Hey everyone, it is office hours. Let's do some chapter 15 homework. Hopefully people are doing well. We can complete the fall homework. My hair is a little longer again, not too long. But I hope everyone's doing well. I need to move the lights closer again. I'm gonna do that really quick. My gosh, it's so much bright. Okay, that's way too bright. Oh my gosh, what have I done? Maybe I took it out. It's better. Brighter lights in the face. Bright lights. Okay, let's do some chapter 15. Chapter 15. Homework. Gonna do the full homework and explain how to do the questions. Let me see. Did it really just close out of that? It really just did. Never go between screens. Never. Never. Let's do anything else. Sometimes it just says no. Let's go back. We're gonna get it going. I think we're still playing music, so we're still chilling. Chapter 15. Placing the questions. Let's do it. Okay, here we go. So we're going to start up the homework here and explain how to do some of these problems. We need to get Mewbot awake too, though. There we go. Mewbot waking up. First problem on the assignment. So right here, we are looking at, let me mark it in the notes. Step 201. Chapter 15 homework, question 1. So on this first question, we're talking about hypothesis testing. And what do you need to know for hypothesis testing? We have to know about the null hypothesis. And very important, as Mewbot wakes up over here in the background, very important that you know the null hypothesis has the equal sign. So right here, they want us to talk about the null. And actually, this is a very easy question if you memorize the fact that when we use statistical notation, the null, which is a starting assumption, has the equal sign. So very easy. It's going to be answer A right here because the null has the equal sign. Now, when you write the null, you're saying the null states, and in this problem, we're talking about the true proportion of people who have a heart attack. Very large study showed that the aspirin reduced the rate of first heart attack. The true proportion of people who have a reduced rate of heart attack due to aspirin is assumed to be 44%. And they don't give an alternative, but the only thing that would change between the alternative, you wouldn't write all these, the alternative states, the true proportion of rate reduction of risk for heart attack by taking aspirin, you'd probably say is not equal to, but you could use any of these signs. You could do less than, greater than, or not equal to. And a huge fact you need to know is that when you pick the alternative, that's the worst normal curve I've ever drawn, it's going to pick the way you shade the curve. The greater than alternative shades to the right, the less than alternative shades to the left, you notice right there, and the does not equals shades both sides by reflecting it on the other side. It's going to be very important for later problems. So this sign right here is super duper important, the sign of the alternative, which is the only thing that changes because that's going to determine which way you shade the curve. So you're going to have to find your p-value, and you'll have to know the sign of the alternative for later questions. So null has the equal sign, might be the only thing it asks. That's it. This next one is basically over nulls and alternatives also, and it's not that bad if you know what to do. It's not hard if you know what to do, right? Every task in the world is easy if you know what to do. So we are taking the note, and let's do it. A casino wants to know if the win rate on their casino is really 1 out of 100. Now, when you do a hypothesis test, the best thing you can do is write it on your own without any help. What you're going to be doing right now, at least for this chapter, is choosing between P or mu. If it's mu, it's quantitative, like how much does something cost, how tall is someone, what is someone's GPA. If it's P, it's proportions, which is categorical, like what percent of the time do we win? Like, did you win or not win? Because you're like, but Brian, this right here is a number. Well, but that's the proportion of times you win. So to collect that data, you'd have to say we won 1 out of 100 times. So when you collect that data, you would say, yes, I won, no, I didn't, no, I didn't. And you'll see on other problems, it's actually a quantitative measurement, not the percent of time a category occurs. So the category being winning and the proportion of wins you have. So think, does it make sense to say the mean of wins or the proportion of times you win? And it's proportion like percent right there. And so with this, we want to write the null ourselves because we can write the null, we can write the alternative. So try to do this, grab some paper. This is me hoping you're grabbing paper right now. Did you? So what you want to write first is the null states. That's what that says. We've already got that, but they gave that to us. We're talking about the percent of time we win, so it's going to be P for the percent of time we win or the proportion of time we win. The null has the equal sign, and then we have the hypothesized value. Now this value right here is known as P naught. So this value is P naught. So we state that the true proportion is equal to the hypothesized proportion. Now they are asking in this question, is it really 1% or is it not 1%? So the alternative, the only thing we change is the sign, and we would say, or it's not 1%. So either it's true that it's 1% or it's not 1%. So that's got it right there. So we are going to use P as the proportion and let the true proportion be equal to, because this is the null, and the alternative is that the true proportion is not equal to, because they're just saying, is it 1% or is it not? You'll see on other ones, we get what's called sidedness with less than, greater than. The next one you notice immediately has a dollar value. So remember our notes from earlier? Well, dollar values sound more like quantitative. So when you're doing dollar values right here, you're definitely dealing with the mean. So we would say the null states that the true mean of what people spend at the website is $32.26. Remember, the null has the equal sign. So every time you do it, the null has the equal sign. So make sure, there you go. And then the alternative we're looking for, has it increased? And this is what goes to the sign of the alternative. The researcher's question, a definite teaching to the test moment. So when you say, has it increased, we're asking, has the mean increased? And I want you to notice this. Please notice, when you write the alternative, the only thing that changes between these is the sign. The only difference between the null and the alternative is the sign. So once you write your null, you know you're testing the mean, and because mu is the mean, mu, mean. Well, then the true mean, null has the equal, so we got that one for free. Then we put mean here, because that's not going to change. And then we need to say, has it been increasing, which means greater than. Is it true? Can we show evidence that the true mean is greater than 32.26? A pharmaceutical company is trying to see if the cure rate is greater than 20%. So if you notice, whatever they're trying to investigate and find evidence of is what they're trying to give an alternative. So using our knowledge on whether someone is cured or not cured, we can answer, is this P or mu right now? Does cure sound like a mean thing or a proportion of cured, like an average cure or a proportion of people cured? Well, it's going to be the proportion of people who are cured. So the null states the proportion of people who are cured. What does the null have next? Null always has the equal sign. And then we have the hypothesized value, that is P naught. I should mention on the last one, it was mu naught, which is the hypothesized mean. But that was the previous problem. I just didn't mention, I feel like I should have, that it was mu naught on the last problem, the hypothesized mean. The hypothesized value is 0.20, so you could literally write P naught equals 0.20. That'll be important for solving later on if we solve the equation P hat minus P naught over P naught Q naught over N square root equals a Z star, or Z score, excuse me. Not a Z star though. The alternative hypothesis is that the true proportion, we're trying to see if it's greater than, so that gives to the sign of the alternative, which is the only thing that changes. So the only thing that changes is what we're looking for evidence for. So the proportion, because we're dealing with whether you're cured or not. So it's proportion of people cured. And we're trying to see if it's greater than, where did I miss a blank? Null has equal sign. That's the freebie. Everyone knows that. And right here, we see the bank is trying to demonstrate if the people using their website has decreased from 30% since it crashed. So we can do this one pretty quickly because we're doing a lot of these. Well, it's the proportion of people using their website, because do you use the website or not is a categorical question. Do you use the website, yes or no? And then we would say it's equal to 30%, and they're asking, has it decreased, which goes to the sign of the alternative. And where it's the researcher's question, not the data, that helps you pick the sign. Well, that was an easy one, and this one might be as simple too. We're just rocking and rolling through these. There we go. Let's copy it and do. Oh, man. I need more coffee. Maybe. Which one's the null? You know we got this. You know it by now. Null has equal sign. Is that it? That was too easy. That was too easy. Now, the alternative, there are two answers here that are directly wrong. If this was, hey, DD, good to see you there. Chill, office hours. We're doing nulls and alternatives. So there's two answers in this problem. Do you know which two answers? Good morning. I meant to message happy birthday. I know it's like days gone by, but I'll throw you some 5 level points, DD. You gotta see how many points you're at. You can check your points anytime. You should have a good bit of points. I reset them every once in a while. You're welcome. No, that's awesome. Glad you're having a good time. Yeah, read the question. Which answer do you think it is? Take a shot at it. And 1233. Here we go. Tom stamping these. So it says, suppose I want to test whether students' textbooks cost for the semester are higher on average than the cost of $450 in 2000. Nice. You had showed up to class level. We're trying to see if it's higher than $450. So, which one would it be? A, B, C, or D? Is it higher than $450? Do we have evidence it's higher than $450? It is A. And that says the true mean, not the sample mean. That's the sample mean down there. So it says the true mean is greater than $450, and that's the alternative. And here's a bit of a bigger one. Let me take the timestamp on it. This is a bit of a bigger question. Okay. A test preparation company claims that 60% of students. So immediately,
notation, brother.
You gotta do notation. I don't care if the question says notation or not. We're doing notation. So a lot of people forget this, but whenever there's a claimed value, it becomes the null value. And so this, since it's the percent they believe to be true, it's going to be the hypothesized proportion. And a company claims that more than, so they would be claiming the alternative hypothesis, right in HA right there, that the true proportion is greater than 60%. And when they talk about one-sided and two-sided, one-sided is if you do a greater than or less than because you would shade to the left or you'd shade to the right. Two-sided is when you reflect it on both sides. So very clearly, this is a one-sided alternative. This is one-sided, one-sided, two-sided. So we can tell that this test is naturally one-sided because the company wants to see if the scores are higher. So if they wanted to see not equal to, it would be a two-sided, but they're trying to see if it goes in one direction. If the p-value is low, we reject the null. If the p-value is high, just let it fly. So let's kind of talk about that here just briefly. I got the wrong person screen. If the p-value is low, reject the null. If the p-value is high, just let it fly. What does that mean? Well, with this, we have what is called alpha. Do you know what alpha is usually set to? I'll leave it blank for a moment. This is where, if it's below, we reject. If it's above, a lot of times you'll say fail to reject. Not sure, no worries. Alpha is usually 0.05. Classic number in statistics, 0.05 alpha. Fail to reject. 30 more points. Fail to reject. So we have to have a p-value. Like if we get a p-value of equal to 0.03, we'd reject the null. But if we get a p-value, where like PV equals to 0.20, What is p-value greater than 0.05? That would be a p-value that is higher than the typical alpha. So the p-value right here, p-values, let us see, and that's such a good question. It's like this, and I'll do my favorite example with it. So let me explain what p-values are and how we use them. Oh my, really? I love it. This just pops up randomly all the time. Random news. Just love the news popping up. So I like to say, let's say I claim I can run a 6-minute mile. So Didi, if I say I can run a 6-minute mile, what would you expect me to do? If the claim is Brian's, I have no clue. If the, I missed the news. If the claim is Brian can run a 6-minute mile, what would you expect me to do? If you expect me to run a 6-minute mile, what would you, if the claim is I can run a 6-minute mile, what would you expect me to do? I kind of said it a moment ago. We'll do greater than. You think I'm slower than 6 minutes? If the claim, you'd expect me to run around 6 minutes. Exactly. That makes sense. Like if I say I can run a 6-minute mile and they see me run, you expect me to run a 6-minute mile. So the most likely thing goes at the center of the curve. This is the null value. The null is what we believe until there's evidence to believe elsewise. So the null, which is associated with that symbol right there, is the original belief. Now, what you do is you go out and take a sample, and you observe me running a mile in 6:01, on average, maybe over a couple miles for a week. So I would land maybe right here. Now notice, did I land exactly at 6 minutes? So is this mile time right here exactly at 6 minutes? Is this mile time right there exactly at 6 minutes? Is that exactly 6 minutes? Or we should do that in yellow because that is the null value. So it's the same thing as writing null. That's where the null is at, center of the curve. That's not exactly 6 minutes, right? I'm a little slower than 6 minutes. But now we get into what is a p-value. This is a p-value. Notice this is the percent of the curve that is higher than the result. Is this a lot of the curve, yes or no? Is that a lot of the curve? Like imagine this is a bar of gold and you say, give me some of that gold. And I say, here, you can have the shaded region I drew in. Is that a lot of it? We're just coming up with a number. Well, it is less than half. Remember, this is gold. So, I mean, this is maybe like 46% of the curve. Is that a lot of the curve? Like in just terms of a bar of gold. And I say, here's 46% of my bar of gold. You know, that's a lot of the curve. Or like pizza. It's a weirdly shaped pizza. And you're like, that's a lot of the pizza. It's less than half true. But do you see how it's a big portion? If I tell you you have a big interview today and there's a 46% probability of rain, do you think it could rain? So yes or no? If I say there's a 46% probability of rain today, if I say there's a 46% probability of rain, you would take an umbrella, right? Now you'd say it's more likely it's not going to rain, but it's likely that it's going to rain. So what does this mean for our result right here? It means if I am a 6-minute mile runner, then watching me run it in 6:01 or longer would occur 46% of the time. So that means what you saw me do was probable, like a thing that's probable. It happens 46% of the time for 6-minute mile runners. Given I'm a 6-minute mile runner, the probability of running 6:01 or higher would occur 46% of the time. Yep. And then you go to the counter example where it takes me 16:01. And think about this, with 16:01, what's going to happen is the observed result is going to be way over here now. And this is going to lead to a very what p-value. Since this is where the observed result is, the p-value is going to be very, very what? It'd be even probably further over. Very tiny. So when you think about what this means is if I say to you, well, I'm actually a 6-minute mile runner, and you're like, no, I saw you run it in 16:01 on average. So what I saw you do is very unlikely for a 6-minute mile runner. I reject that you are a 6-minute mile runner. I have evidence it takes longer than 6 minutes. So you'd reject that I'm a 6-minute mile runner because what I did is very improbable. Like you'd say, if you're a 6-minute mile runner, it shouldn't be taking you 16:01. That is a very unlikely result to happen. Like, I'm like, well, it could happen like 1 in a million times. And you're like, yeah, 1 in a million. I'm not going to go with that probability. I'm going to say I reject. So is there a statistical test with the p? Correct. So what the p-value is used for is this test right here was the test to believe that Brian is the 6-minute mile runner or find evidence, well, to continue to believe, I should say, The test that we should retain that Brian is a 6-minute mile runner, that's proper statistical wording, or have evidence that Brian takes more than 6 minutes. And we in this test said there is strong evidence to conclude that Brian takes more than 6 minutes by rejecting the null hypothesis of Brian being a 6-minute mile runner because our p-value of 0.000001 is less than our 5% alpha. The 5% alpha relates to this side of the curve in this example, where 5% of the curve would be shaded. And since we landed way to the right of this, our observed result is less likely than this threshold. So this is called sometimes the rejection region on which you would reject anything from here over. And our result landed way to the right of that. So we have extreme evidence in this scenario. So we had something very, and think, you don't reject for things that are towards the center, towards the null. If you land close to the null seems believable. So it goes for this example we were just doing, perfect little mini lecture. If the p-value is super small, then there is evidence to reject the null. Just like with the running thing, we would reject the null and we'd have evidence that it's greater than. Remember, we're trying to see it's more than. The test was to see higher than, and if we have a low p-value, you can reject the null and say evidence of greater than. So this is going to be highly dependent on one standard deviation. True, standard deviations do come into play. And with the p-value high, we just let the null fly. There is not evidence for the alternative that it's greater than, because we're still testing to see if it's more than. So, yay! Oh, you got this. And here, you ready? We'll put this next note. In a criminal trial, one option is to declare them not guilty, which is the starting. What do you think that would be related to? If you start the trial not guilty, and then you end the trial not guilty, which of these sounds right? If you start the trial not guilty, and then you end the trial not guilty, which of these sounds right? And there's a trick. Do you think it's A, B, C, or D? Or not D. Well, here's the thing. And we're going to have MuBot talk to us for a moment. So in statistics, there's words we don't like. And MuBot's all mad. We either reject or fail to reject. And I put fail to reject here because that's the classic way of saying it. Fail to reject is the same thing as saying do not reject. And you either reject the null or do not reject the null. We don't like the word accept because it's almost like you believe it's true. Like, I accept that Brian's a 6-minute mile runner. What we do, like in science, how you know science is all tentative. So, will you marry me? I do not reject you. Exactly. There's a lot of memes on that. Like, there's a lot of like Ryan Gosling meetings, like, girl, there's look up Ryan Gosling, I fail to reject you. There's a lot of, look up statistical memes on p-values. There's a lot. And just think about this. What you're saying is, in the mile example, you don't believe that Brian is a 6-minute mile runner if we go back to the time that I landed within what was believed to be likely for a 6-minute mile runner. You're just saying, I don't have evidence you're not. Does that make sense? Like, you're not saying, I accept you're a 6-minute mile runner. You're just like, well, it's believable. What I saw you do is believable for a 6-minute mile runner. I'm not saying you are. I'm just saying you landed within what is expected for a 6-minute mile runner. So I will not reject that. So that's why I like saying not reject. Fail to reject means the same thing. You either go to the mall or you fail to go to the mall. You either reject. Yeah, it's like you're just saying, well, it's believable. Like in science, we hold things tentative. It's not that the theory of general relativity is true. We don't have a better theory for it. So what will we do when we have a better theory than the theory of general relativity? Think about this. Use the wording from this lecture. When we get a better theory than the theory of general relativity, we will what the theory of general relativity? So when we get a better theory, we will end up whatting the theory of general relativity. We will reject it because we have evidence for an alternative. So the alternative is a more likely thing. And that's because science is always updating. And it's not that general relativity was wrong. It's just we get a better understanding and we're always measuring and trying to understand how things work because these are just explanations of natural phenomenon in the world that we have for the data. So we will fail to reject the null in this scenario. Yeah, we don't accept the null. That's a bad word. Which of the following occurs if the p-value is not very small? We observed, finish my sentence, was very what? If the p-value is high, it should just say high. People use Newtonian physics. Yeah, we still do, even though it's not perfect. I think a lot of people use it. It's like, it doesn't calculate everything perfectly, but it's still usable from what I've heard. I don't do physics, though. If a p-value is not small, it's high. And if it's a high p-value, p-values tell us probabilities. It means that what we saw was probable. So it might be what we saw today was not surprising. DD, you got it. We saw something likely and we would not reject the null. There you go. And here we go with the big one. This is the one everyone came to this video for. Everyone's like, DD. This is the big one. You ready? So there's tricks for this. You ready? Trick number one for this question, as I take the note on it, is the null has the equal sign. The null has the equal sign. So what's the answer here? A, B, C, or D? So just go in order A, B, C, or D. The null has the equal sign. It's a statement about what we believe is true. The null, which is a starting belief, has a population parameter, mu, true mean, equals hypothesized value. And great job right there in the chat. More points. An important thing to note is that 23.3 is known as mu naught. So this is the hypothesized value. To figure out the sign of the alternative, we have to see what they're trying to analyze. And in this question, they're saying, has the age of marriage increased from 23.3? That is what the researcher is questioning. Has the age of marriage increased? The sign of the alternative, which is the only thing that changes, is based on the researcher's question. And you got it. First answer done. Now the next one, and shout outs to my students who came to office hours, because I will get this right. It's so easy to make mistakes on these. What we have right here is condition 1, condition 2, condition 3, and I want to point out that this requires memorization for the test. We're popping review 3 material in the chat right now, and what you'll notice with review 3 material is that it goes over, once Mubot drops it, come on Mubot, there we go. It has a video going over all the conditions, and I start by saying, every time I hear the video, I just hear myself saying, there's the and here are all the conditions. So we are doing a t-test right now. And to do a t-test, condition 1 is random. Condition 2 is less than 10% of the population is sampled. And condition 3 is nearly normal for the t, 2 sample t or 1 sample t. Independent means is the fourth condition, but we're not doing 2 sample t. We're also not doing chi-squared, which is 2 categorical variables. And we're not doing 1 proportion. But please check out this playlist right here. It's up. We've got practice videos for the third test. Even Long Hair Brian doing some epic speedrun reviews right there. You can check them all out. Good stuff. And get some... Oh, that's me teaching right now. Let's do a Brian Inception. Oh. Hello. Hello. All right. All right. I'm having too much fun. I'll sometimes do it like this, and then I'll just create like a tornado of Brian's. Long hair Brian, yep. And so here we go. Let's take a look at the conditions. The independence condition is the randomization. You take a screenshot. Yep. Well, it's in there if you go to it. The independence condition right here can be no. Random. That means we got it. Definitely met because took a random sample. The nearly normal condition is reasonably assumed. I hate that because the population... We made one mistake earlier today. Okay, we got it right. Okay, come on, Brian. You got this. The independence condition is definitely met. The nearly normal condition can be reasonably assumed. Wait, no. Okay, yes, this is where we made a mistake because the sample size is large. This is it. Really? Really? It should be used. The independence condition, don't tell me this can be reasonably. That is the worst question I've ever done. It says they took a random sample. That was the mistake I made during office hours. That was the mistake. I had everything right except for, I guess taking a random sample doesn't mean that they're independent. Well, if they're random, why would they be dependent? Ma Pearson, come on. That is ridiculous. Well, you've got the answers right here. Sorry about that. I don't like the way I phrased that. The independence condition is just another thing that can be checked via randomness. That should definitely be met. And they don't even have you explain it. It's just a click the button thing. Yeah, oof. They don't even have you explain it. What you should know, especially for this question, is the test. For this question, we need to know what statistical test we are using. The statistical test we are using is taking the t with n minus 1 degrees of freedom, found, thank you for DD, y bar minus mu naught s over square root of n, which means it's time for
Notation,
brother. So you have to know notation for the final. And you notice right here, they do give the equation. There's the mu naught. The standard error, it asks, what is the hypothesized mean? And here's the s over square root of n. So the hypothesized mean is 23.3. That's always what goes here on the other side, either hypothesized mean or hypothesized proportion. And that is what mu naught means, hypothesized means. And then right here, we would put in s over square root of n. N is 40. We sampled 40 individuals. And there are 39 degrees of freedom. Oh, clicked the wrong answer. The way the degrees of freedom are found is by taking n minus 1. Since sample size is 40, degrees of freedom are going to be n minus 1. So let's check the answer right there. And now we get down to what is the p-value. The p-value, I could probably get it. I'm just going to go with that. Darn. So it's so close to that, whatever it is. It's so close. Oh, sorry about that. Thank you. Yeah, you need the t-statistic. So if people are wondering why I'm guessing this, the t-statistic is plotted on the t-curve. So it's telling us, it already solved the equation. It was something like 24.4 minus 23.3 over, and then like 4.1 over square root of 40. And it's telling us that this is about equal to 1. And so, oh wait, 5.5.3. Oh, did I get the wrong numbers? I think I was kind of doing it a bit from memory. That means we landed over here at a t. Well, so the t is at 1. I see where you're going. You're on the right track. This is what it looks like visually. And the reason I'm guessing what I'm guessing, and there's some decimals after this, is because of the following rule, which is the empirical rule, but the t is kind of like the normal. So I know the answer is going to be close to 16%. We also had to know that the alternative hypothesis tests for greater than, so mu greater than 24.4, or 23.3, I think it was using, because that's the hypothesized value seen here as mu naught. So all we have to do is go to the t-curve and input the value with the right degrees of freedom. So my guesses are probably pretty close. I'd probably guess 0.152. I'll put it in the chat. That's what I would guess. Elsewise, we'll see if I would have got it or if I would have lost in my third attempt. So we go to find the p-value using t. We want to go to above because it's a greater than test. Degrees of freedom, 39. And then we want to enter in the t-statistic it states in the problem of 1.035. Wait. Yeah, okay, I think we're doing it. We're doing it. Let me see. What was my answer? No, it wouldn't have won. I wouldn't have gotten it with this. It really has to be that accurate. I was so close. And once again, it's because when you think about it, it's very close to just one standard deviation. And I want you to look at this. Does this drawing right here look a lot like what I drew? What do you think, Didi? Does this look a lot like what I drew? Do these two drawings look very much similar? So once again, you can draw a little sketch and think about what it should look like. And that's the key. You want to be able to do these sorts of things for these problems. Like it's knowing that the t-statistic is then plotted on the curve, and this is the actual t. Very close, exactly. So you have to put in the actual value of the t, which is 1.035, and we're graphing to the right because it's a greater than test. Yeah, and you'd fail to reject. This is a high p-value. Yeah. The p-value is the probability of seeing a sample statistic of 24.2 or older. given the null is true. That's what the p-value tells us. And it's using the 0.05 alpha, which if we go back to our drawing right here, that means our rejection region is over here. And the 5% over here, if our result lands in there, then we reject. So we did not land far enough away. We did not land in the rejection region. So we would not reject the null. There is not evidence the alternative that the ages are greater than. So we would not have evidence that it's greater than. And we've just done it. That's the full entire homework. That's it. That is the full homework. That is the full homework. Go to sleep. Go to sleep. Oh, man. I don't know why, but like 5% still feels like a lot, to be honest, now that I think about it. Well, so here's the thing. Let's watch this. So let's go to ChatGPT. Say hello. Okay, here we go. ChatGPT. In statistics, I don't want to use a 5% alpha. Can I use a different alpha like 1%? And the answer is yes. So yeah, well, what it's called is your type 1 error rate, and it just said type 1 error rate. So because with the 5%, you would do 5% of the time you would reject the null when you shouldn't. And so your alpha level, this is actually chapter 16 in the book, your alpha level is actually the percent of time you would reject the null when you shouldn't, because 5% of the time you're going to say you have a result when you actually don't. So if you make alpha lower, you make less errors, but you find less things because you're more picky about what you say is a result. By decreasing alpha, you would take this rejection region and make it smaller, or further to the right, rather. So that makes it harder to reject. So now you have to land further away. You have to have a more significant result to find something that is going to reject the null. So this might be a rejection region of like 1%, and you make it harder to reject, but you lower your type 1 error rate. All models are wrong, some are useful. George Box. All models are wrong, but some are useful. There you go, George. Good old George Box. There we go. And the goal, as it says, is just finding a model that works, that helps out. And we need to find what's useful. So it's very tough with different industries. It's so crazy what it knows. ChatGPT is nuts. My dad met George Box. My dad met George Box. I don't know how to spell astronaut. It is so my brain. Gosh, it knows like sarcasm. That's what I'm starting to worry more about. Or it knows that those combination occurs. I look into things like, does it know like things get it? Doesn't it get interesting right here, DD? Like, it's getting cringe though. Please tell me he's suplexed a t-test on the moon or something. No is a weird word, but I would say it pattern matches. Yeah, but like, how did it pattern match that astronaut pro wrestler? I guess those don't go together much. But how did it think like when someone says this is a career? Think, I know I'm saying think and no. The pattern matching that exists to like it's just interesting. It knows like the juxtapose. And if I say, do you think my dad was really that? It'll probably say no. I don't know. I mean, I know it's not thinking. I understand what large language models do. What worries me these days is there's a lot of AI stuff out there now that people are not saying is AI. I think there needs to be there needs to be AI transparency at all times. That's probably the biggest thing I want is AI transparency, that we know what is AI and what isn't AI, because more and more people are creating things with AI and not saying it's AI. Like I'll look on YouTube and there'll be like AI thumbnails of like, this is happening. And then I'll look and I'm like, that's an AI image. But the problem is, as AI gets better, like if someone posted that thumbnail like 10 years ago and I didn't have my AI literacy, like you go back in time 10 years ago and you post an AI thumbnail, I think it's a real thumbnail. I would think it was a real, to quote, right, for this reason, I don't use it. Good idea. Yeah, I really, it's funny to me, like, how little, like, I'm pretty out of social media, too. I think a lot of times social media and everything keeps us all in one sort of train of thought and directs us, whatever lane we choose of thought. It's almost like you stay in that lane and you don't diverge and don't change opinions. You just kind of think what is groupthink. You know, that's what it's called. It's like, you get into the lane of thought and then you don't grow your mind from the echo chambers. Yeah, groupthink, echo chambers. So it's tough for me because I believe what I believe. I have a lot of opinions on stuff, but I try to take in a lot of outside sources, and not that I'm like gonna be like, oh, you're right, but I want to hear things that challenge my thoughts, and then I'll disagree with a lot of them, and then maybe I'll change their minds. But you have to get those. You can't be in the echo chamber, because then you just gonna. How do you know you're wrong? If you don't get any out, it's like having, my spouse or someone was just like, you're right, you're right, you're right, which she doesn't do that, luckily. But that would be so detrimental to me. What's up, Colin from Disney? ChatGPT or Copilot? I'm a ChatGPT. Are you which one are you, Colin? Yeah, exactly. Purposely designed to maximize what? Yeah, exactly. That's what a lot of algorithms do. That's the why optimize. I think that's why YouTube a lot of times doesn't. Disney makes us use Copilot. Oh, interesting. So yeah, we got a lot of different people from different. We're just chilling for a moment. Microsoft Teams, all that stuff. I use Teams. I do like Teams a good bit. I'm more Teams than Zoom, actually. I like Teams better than Zoom. I just like the features. I like kind of the offline chat mode of Teams. So I'm more Teams than Zooms. Claude. Claude is. I haven't used much Claude. I might start using Cursor. I've got to design something this summer, which Colin, we should talk about that. I'm gonna be. I'll tell you those things about that. I'm so excited. Tell me. I saw your messages. So, I guess just chill time here. I'll go to the chill screen. I gotta set something up. Keep talking here. I was gonna play music, but we'll just chill. We did the homework. We'll save it in the video. I'm gonna set up a quiz. Quiz for my class. A quiz. The quiz. This semester is almost over. It's a long time. Oh, you talk about grading. Let's see. Yeah, you were telling me. Did you do it for your birthday, was it? Or you were telling me that? Myers getting graded. I think you mentioned that. Maybe someone else did. Yeah. That's what it was. Would you? I love it. Colin's comment right there. That is awesome. That cracks me up. Yeah. Without context. Sounds crazy. Let me see. I have to solve one equation. I need to play it. I've heard good things about it. They make those other games, right? Like that's a company that made Cards Against, I think, or something. So yeah, like we like playing card games. So different group. This is the oatmeal. Oh, but they have an app for it too, right? My wife had me play there's a game you play on the phone with that. So she had me play the game on the phone. She was way better than me. And it made me like way better. And I think I'm good at video games. I thought I was good at video games, but apparently I'm not. So Apparently, I'm not. Oh, I play Pokemon Go all the time. I can see if I got any new shinies as we're just chilling out here for a second. But no, I play Pokemon Go every day. Every day I play Pokemon Go. A lot of shinies, tons of stuff, and then solve the equation. Okay. I'm setting up a quiz right now. Then we're doing pizza next week. Oh, there's so many Pokemon here. There's a billion Pokemon right next to me. I'll turn on my clicker. But around here, there's so many. Where's the shirt from? It was like, I got given it. This is the second time I've been asked today. Yeah, it's like, I think it's for a group. I don't know what that is. I was just given it. They're like, hey, you want a t-shirt? I was like, yeah. It's a really soft UT orange shirt. So I was like, soft shirt? I could take a soft shirt that fits well. I was like, yeah, it's fine to me. But soft like heather t-shirts, I think that's what it's called. Those are my favorite. And this is probably one of the like just nicest feeling shirts I have. Like, you ever get those shirts that are just like so rough? Oh, dude, have I seen Invincible? I bought the comic. It's that good. The Invincible. DD, have you seen Invincible? And Colin, I guess you have, or DD has maybe too. Invincible is so crazy good. That show is amazing. Yeah, I'm very, 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 very obsessed with Invincible. Yeah, that's what my wife says. She feels the same way you do. She's very much like, she hasn't seen the last episode yet. She hasn't seen the last episode of the season. Would be the meme produce the memes. Oh, well, I'm trying to make it. I need to make, I was going to do that today and then I went on some walks. I want to make a title screen of Stat Tool 1 with the yellow graphic. I wonder if I could just ask ChatGPT to do that. Watch the task be that easy. So, reproduce a replica of the Invincible title screen, but with Stat Tool 1 and subtext created by University of TN Knoxville. ChatGPT is really bad with words, and we'll see what this does here in a moment. I'm finishing up this small task, but ChatGPT is just so bad with words. It's just, it's trying it. Invincible won't be in its training data. Yeah, you're right. It might. No, they update ChatGPT. Did they not with like 4.0? What did I do this question? Solve the equation. We'll see what it does. I'll go back to the, take a picture from the internet and put it in there. Yeah, upload it as a reference picture. That's actually a really good idea. We'll see if we can do this task while we're just chilling here for a moment. We did already the assignment. Invincible title screen, title card. Okay, here we go. I got the blood on it now. Okay, let me take this. I'm doing 10 things at once. Okay, it's taking a while here. I'll go to the main screen. I can be here pretty early. I got a few like random things to do, but just let me know, and then I can be there. Okay. I gotta look at an equation real quick and make sure I know what I'm having people solve. Okay. I know. It's just gonna take an hour. I'll see if it does it. Oh, you can't see anything. Go over to Germany? I should. Whoa. Oh my gosh. This is not horrible. What do you think? That's not horrible. And it's actually doing text better. So that was the prompt. Reproduce a replica of the Invincible. It's not horrible. And if you were to stretch this out right here, you know, you just take, so I already had the Invincible graphic there, and we could just Photoshop, I hate that one all the way to the edge right there. You know, we just take, we can do it in a Word document easy. And then I got like a few minutes left. We just take here, drop this like this, and then we grab this is like how you do really bad photoshopping. Someone's like, he does Photoshop, and they're like, no. And then we go background, and then we go bigger. There you go, look at this. And then we'll screenshot again. I should have brought this. Oh, it's because I cut the edge of that. No, okay, there. There we go. There we go. Okay, there. Let's get the cursor out of the way. You say welcome to a real... Yeah, I know. I need to find... Actually, this might have just done the task that I've been meaning to do. And there's the widescreen of it. So there it is right there. I mean, what do you think? Caught a little bit of the border on that. Doesn't look too bad, right? It's not too bad. Let me save it. It's crazy. And so what I can actually do, watch this. Let me do this. We're doing tasks right now. Okay, Stream Deck. Which one of these am I not using? I haven't used this button in forever. I don't even think it does anything. It doesn't do much. Okay. I'm more in the other direction person. Here we go. Let's see if I can get this loaded up here. And image, convince. Okay, create new, browse, pictures, with minutes to go. Invincible, got it. I don't know. I did. Bob's Burgers. Bob's Burgers, good stuff. So there's that, and then source visibility, replace, add image. I want to use my own icon. Set from file. Oh, pictures. With minutes to go. Okay, there we go. And Invince. Mubot never forgets anybody. This is desktop. Vince. Boom. I need to have it like hit with a noise. I could set that up. Be like, welcome to. People have been asking for that, and now we just did it. Just sometimes I think of a task and just what you can do. Bow. That looks pretty good, right? By University of TN Knoxville. I actually did it. I don't know. Well, that's our time. We got an easy, fun task done. Just ChatGPT is insane. Who knows where this world is going. With that, we'll be back tomorrow. Bye for now, everyone. Bye. Wait. Sorry. Yep. What is Batu? What is that, Colin? You don't have to bring me anything either. Colin is a former student. Think about it though. Think about what Bob's Burger. I think more of the other direction person. Bob's Burger's favorite team. Bob's Burger's good stuff. I don't know what Batu is. What is that? Star Wars. Oh, cool. I was talking to a former student, really nice guy. He's a huge Star Wars fan. He was telling me about this dude who's like got blue skin. He's part of the Empire or whatever, and he was like, you can figure out like the culture. You can figure out like the attack things of another group by looking at their art, and like he did all these things, and he was like telling me how cool he thinks he is, and he's been watching Andor. I'm thank you, Colin, so much. I appreciate it. I grew up, I didn't watch Star Wars growing up. It's very kind of you, and I appreciate that. But I'm gonna head off. I got class in 4 minutes. Bye for now, everyone. Bye.